Good morning. So last time we covered, we talked about bar chart and pie chart. So we are going to continue with graphing. By the way, for the graphing stuff, I'll just briefly go over these things right now, but we are going to revisit them when we do the little programming with Python, okay? So right now it's just a brief overview that I'm going to give you, and then when you actually sit down and work with a small piece of code and small set of data, then you'll be able to get a more solid understanding of all of this, okay? So let's go ahead and talk about stem and leaf. Stem and leaf plot right here. So these are the ages of a bunch of students in a class. All right. So we are going to create a stem and leaf plot for this. I probably won't do it for all of these data points because it may take a little time, but I will give you the idea on how to do it. Now, what is the objective or what is the reason we do stem and leaf? The reason we do stem and leaf is that it gives you an idea of the shape and structure of the data, how it looks. Remember, we are in descriptive statistics as of now. So remember, we are in the descriptive statistics part, and we're gonna continue to talk about descriptive statistics and follow along. Inferential statistics is gonna be towards the middle of the class and onwards. Now, it describes shape. So look at these ages. So what you can do, if you look at these data points, you can create a rule, very simple rule. People in this data set have ages in the teens, they have ages in the 20s, they have ages in the 30s, and I don't know if anybody in the 40s, 50s, and 60s. Looks like there are. So you can do the following rule. All the teens are going to fall under 1, 20s under 2, 30s under 3, 40s under 4, 50s under 5, 60s under 6. Now we look at the teens and then go ahead and cross them out. So there is an 18, 16, 19, 18, 17, 19, 16, 19. So let's write them down from the lowest. So the lowest number is 16. So there is 116. So I'm going to put a 6 here. Is there another 16? I thought I saw another 16. Is this a 19 or a 16? This is a 19. 19. There is another 16 here. So we'll put 6 twice. Then how many 18s are there? 1 18, 2 18s, right? 3 18s. Oh, I missed an 18 here. What is this one? Oh, there is 17. So there should be 17. This is a 17. So this is another 18. And that's it. So there are 1, 2, 3, 4, 4 8s. So you'll put 1, 2, 3, 4 8s. And then 19s. How many 19s are there? Let's see. 1 19, 2 19s, 3 19s, and 3 19s. So I think I made a slight mistake. There are that many. So 3 18s, I think. And I counted 19 as 18. So 3 19s. So 1, 2, 3. And then you can see, you get the idea, right? How it's done. So you create sort of like a horizontal bar here. So writing down all the numbers as many times as it appears. So 16 appeared twice, we write 2 6s. 17 appears once, we write 1 7. 18 appears twice, 3 times, we write it 3 times. 19 appears 3 times, we write 9 3 times. So that's what you do, right? So now I'm just gonna do it one more for 20s. So there is 121, okay, right here 121. Oh, there's a 22. What else? Let's see, 22, 21, 28, 24, 21, 21, and I think that's it. Oh, there's a 15 here. I forgot to put a 5 here. Sorry. You just have to keep a track of it. By the way, you will never do it by hand. Keep that in mind, okay? If you ever do it by hand in the exam or in the quiz, I'll give you something very, very simple data set. This is kind of like, this is not your knowledge when you kind of look for numbers and try to list them. That's not what you are here for. I'll give you very simple ones, but I might expect you to take a bigger data set and be able to use Python and do it. Okay. All right, so let's look at the 20s. There is a 0, that means 20. So this one is gone. How many 21s? 1, 2, 3, 4. There are 4 21s. So we're going to write 1, 1, 1, 1. How many 22s? Is there a 22 anywhere? Have I seen a 22? You guys also look.
One.
Okay.
There's one.
There's one.
There is one. So
By the 19.
Okay, good. There is one by the 19. No 23, I think. There is a 24 I recall seeing somewhere.
Yes, there's 124.
124. Thank you.
125.
125. Where is it? 25.
I want to see the 5th number up. It's next
Oh,
to
yeah.
20.
I missed it even. 25. Okay. So is there any 26s?
I don't see any.
There is no 26. Is there a 27? No 27. There is a 28. 128.
Right, yeah.
And there is no 29 or 30, 29s. Okay, so there is 128. Now I created the second group. Now you go to the 30s, right? So I'll just do up to 30s, then you get the idea, right? How to do it. So 30s, there is 130 here, 130s, 230s, 330s. Okay, 1, 2, and 8. That's it. 1, 2, and 8. Maybe I should finish it because the rest should be easier. Did I miss any 30s, guys? I don't think I did. Okay, look at 40s. How many 40s are there? 140s.
And then for the 50s, you have a 50 and a 52.
For the 50s, I have
A
what do you say?
50 and 52.
50
and that's the
and 50.
oldest. 52, I'm sorry. And those are the oldest.
No, there's a 61.
There's a 61?
Yeah.
Oh, next to 52. Oh, I didn't see that one.
So 61 is there. Is there anything else in the 60s? No. All right. So now we finished the stem and leaf diagram, okay? It's called stem and leaves. So this is first column. Normally they put a space here, a little bit of space here, okay? A little bit bigger space. So this is the stem part and these are the leaves. This is the stem part and these are the leaves, okay? Can everybody make the stem and leaf diagram now? Everybody okay?
Yeah.
Yes.
Yeah.
Very simple. In the exam, if I give you something like this, will be with probably 10 data points at most, okay? But in the computer, you'd be using a lot of data points, okay? In the computer, you'd be using a lot of data points, and it's gonna do it for you. It's kind of like, honestly, people hate math and programming in general, particularly in our country, in the US, okay? Math, science is not appreciated as much. Sometimes you guys don't realize that math and programming is so powerful. It's like amazingly powerful how things can, these things can change your lives. Don't think that I'm saying it because I teach math and I do a little bit of programming. But it is the case. But one thing is very important also in addition to this. So this is something I kind of want to tell you guys. Just don't study things like hardcore science and math and programming or computer science, whatever. Not only do these things, you need to be able to relate these things, communicate these things to other people. That's when the power becomes very important. You not only that you're a good computer programmer, but you can relate the ideas to other, you can talk to other people, as well as you can take the knowledge of computer science, you can apply it in the social and business context, particularly business context. You can take the idea of computer science and apply it to business contexts. You can think of some basic ideas like Amazon. Amazon is one of the largest companies in the world, okay? And they do a lot of programming. The whole entire business is based on programming. And then through programming, they created an infrastructure where they sell things. And even more absolute example of programming is Facebook, Microsoft, Google. These companies, they don't have physical assets as much. Their asset is intellectual. Mark Zuckerberg, he took the idea of connecting people and he thought programming could be used in a way so that we can connect people. See how powerful ideas become? So it's very important that you guys learn programming and math, and then take these ideas and apply it into business context or social context in a way that it becomes profitable for you. It becomes a business. You have to think of it that way. When you're younger, you don't think of it that way. You are more emotionally driven when you're younger, okay? You have to be a little bit mature. And it's true in anything, any subject you feel, any subject or field you study, you take the ideas and try to create a business out of it. That's when you become an entrepreneur. That's when you become successful. All right. Enough of this. Now we're going to talk about some other things involving this. One is histogram. All right. We're going to talk about histogram. Remember bar chart? We talked about bar chart. Bar chart was for categorical / numerical data. It's for categorical / numerical data. However, histogram, sorry, I meant to say not numerical, I meant to say nominal. Sorry, I meant to say nominal bar chart. Now, histogram is for numerical data. Histogram is for numerical. The way you create histogram is this. So let's say this is a data point, the data set, a set of data points came from somewhere. We want to create a histogram. Very simple. First, along the horizontal line, you put something called classes. And along the vertical line, you put the what we call frequencies. Okay. Along the horizontal line, you put classes, and along the vertical line, you put frequencies. That's what you do. Now, what are classes? So class is something you define. How many classes? So think of age. You can create age groups. Somebody between the ages of 0 to 10, age group from 10 to 20, 20 to 30, 30 to 40, 50, 60, 70. You get the idea, right? This is a rule you defined, and you create the classes. So it's basically arbitrary. You know, if you're the owner of the data set, or if you're the one who is manipulating the data set, you personally define how you're gonna have your classes. Normally, we define the classes in such a way so that all the data points are included, and it visually gives us some appealing view of the data. That's how you want to do it, right? Now, in this case, let's say I'm gonna do maybe 5 classes, starting from 0. So 0 to 2, one class, 2 to 4, another, 4 to 6, another, 6 to 8, another, 8 to 10, another. Now, the first class is the 0 to 2 class. The second class is 0 to 4, and so forth. Okay? So, having said that, now look, there is another thing I'm going to talk about right away. I'm just going to use a different color for it. Something called class midpoint. That's the middle of the class. So what is the middle of 0 and 2? Which is going to be 1 right here. What is the middle of 2 and 4? 3. What is the middle of 4 and 6? 5. What is the middle of 6 and 8? 7. What is the middle of 8 and 10? 9. So these are the class midpoints. Now, in each of these class, how many data points belong? We need to find out. That's going to be your frequency. In each of these classes, how many data points belong? That is called your frequency, or also known as class frequencies. So sometimes you also call it class frequencies. In each of these data points, in each of these classes, the number of data points that belong. So now let's go ahead and do that for our calculation. How many data points are between 0 and 2? Can you look at this data set and tell me, please?
1.
0 is there, 1 is here, 1 is there. How about 2? Oh, there is another one here. How about 2? Is 2 gonna be there? That depends. If you want to include 2, you can, okay? But you have to make sure. So let's say we are gonna include the 2 here, okay? So that means the boundary point belongs to the class before that. So 0 cannot belong to another class before that. That's the starting point. So we have to include it, right? So the boundary point belongs in the class. If you wanted, you could make that rule, the boundary point belongs to the next class. So that's how we are going to do it. So let's say we include it. So it's going to be 2. So how many data points? 1, 2, 3, 4, and 5 data points. So let's say 1, 2, 3, 4, 5. So we're gonna do this. So that's my first class frequency, which was 5. Now from 2 to 4, remember 2 was already included here. So we are looking for actually just 3 and 4, right? So how many 3 and 4s are here? 1, 2, 3. That's it. So we are going to go up to 1, 2, 3 right here. And do this. Height is going to be representing the class frequency. How many data points are there? Now let's do between 4 and 6. That means we are looking for 5 and 6, right? 5, 6, 1, 2. And that's it. There are 2 of them. Five and 6. Then next one is going to be 7 and 8. 7 and 8. 1, 2, 3, 4. Right? So we're going to go up to 4. So 4 is somewhere here. Right here, right? My histogram is kind of tilting to the left. It should be straight, vertically standing. Okay. And between 8 and 10, 9 and 10. So this is a 9, this is a 10, and I think that's all. There are 2 of them. So
There's another 9.
there is another one where I missed it.
Next to 1.
Oh, thank you. 3 of them. Thank you for catching that. So there's gonna be my last one. So that's it. That's how you'd create histogram. What it does, again, it gives you a visual presentation, a visual idea of how the data set looks like. Okay, what kind of shape does it have? And these are things you will see a lot in news and media and research reports and everything. Or in your personal life, you can collect data, you can create histograms and or bar charts or pie chart, etc. Now I'm gonna skip this one and do this one. I'll get to this later. Let me do relative frequency histogram. Now, relative frequency histogram is a histogram where you do the following. You take the total data points, okay? So let me count the number of data points here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 data points. Out of 17, 5 of them fell in the first category. So first class. So it's going to be 17. 5 divided by 17. 5 divided by 17 is 29.41%. So now I'm going to go ahead and do it here. Again, the same thing. 0, 2, 4, 6, 8, 10. 8, 6, 4, 2, 0. Now remember I talked about the class midpoints. We are going to have to worry about the class midpoints. This one, this one, this one, this one, and this one. And the first one is 29.4%. So I'm going to write it here. so that you can 29.41%. Okay, so you're gonna make the height 20. So it's kind of like instead of actually 5 numbers, you're going to write 29.41%. Now you do the same thing, okay? Here, next one is 3, and the corresponding percentage is going to be 3 divided by 17 is going to be 17.64%, 17.64%. Okay, the next one is 2, right? 2 divided by 17, 2 divided by 17, that's going to be 11.76%, 11.76. And the next one is going to be, was it 4? I think it was 4, like that. So it's going to be 4 divided by 17 is 23.52, 23.52%. And the last one was 3, I think. So it's going to be same, 17.64%. If you add all these percentages, it should add up to 100%, by the way. It should add up to 100%. So the difference between regular histogram and relative frequency histogram is in the relative frequency histogram, you just put the frequencies as opposed to the actual number of points. It's kind of like similar, so it really doesn't make a difference. So that's what it is. Now, frequency polygon, okay? So again, I'm going to take the same data set, 2, 4, 6, 8, 10, 10, 8, 6, 4, 2, 0, okay? Now, there are 5 data points in the first class, I remember, right? So I'm going to go 1, 2, 2, 3, 4, 5. So I take the class midpoint and go to the 5th. Now then the next one had, how many? Was it 3? 3, I think. So again, the class midpoint, just the middle, take the another point. And the next one had, I think, does anybody remember how many next one was there? Was it 2?
2.
Yeah, okay, so I'm gonna go to the class midpoint and go to 2 here, okay? And the next one had 4, I think. So go to class midpoint, go to the 4th height, which is somewhere here. And the next one had 3. Next one had 3 right here. So now what you do, you connect these points. And that's the frequency polygon. And then that leads to the relative frequency polygon. Relative frequency polygon. What it is, again, instead of putting the actual height, you put the relative frequencies. So 17 divided by the way we did it, in this case 5. So these are going to be actual. On the vertical axis, you're going to put the percentages. Like in the regular histogram, along the vertical axis, you put the class frequencies, right? In the relative frequency histogram, you just put the relative frequencies, okay? And again, here in the frequency polygon, you're going to just put the relative frequencies on the vertical axis and then just connect them. That's what it is. It's kind of obvious thing, you have seen it before. So this is just kind of formalizing the knowledge. Now, ogive is a cumulative relative frequency. What it is, this is slightly different. So let's use the same data set, 2, 4, 6, 8, 10. So now This one is kind of interesting. What it is, the first percentage was 29.41%. So along the vertical axis, you put the frequencies, relative frequencies. It's actually not relative frequencies. I'll tell you, it's cumulative relative frequency. Cumulative, you accumulate. So cumulative relative frequency. So the first one was 29.41%. So that's 29.41%, let's say here. The second one was 17.64. So you have to add 29.41 to 17.6. So 29.41 plus 17.64, which is going to give you 47.05. So 29.41. The next one is going to be 47.05. The next one is going to be plus. In the third class here, right here, we had 11.76 plus 11.76. That's going to give you 58.81. So it's going to be right around here, 58.81%. And then next one was what was the next one? Let me go back on my screen. Okay, 23.52. 23.52. Okay, plus 23.52. That's going to give me 82.33. 82.33. And then last one, if you add it, is going to come up to 100%. Okay, so now you just connect this thing, and that's what is cumulative relative frequency. What it is doing, it accumulates. It accumulates as it progresses. It accumulates as it progresses. It's cumulative. Next, we're going to talk about time series data. Okay, so this is a great example. Time series data. Time, and maybe on the vertical axis you're going to put stock price. That's a good example. Time series data is along the horizontal axis time, along the vertical axis stock price. Now stock price is a continuous value. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, or whatnot. So let's say you're looking at a stock price somewhere here. Is something like this. This is how stock price behave. So time series data is any data that is dependent on time, and it's continuous typically in nature. Okay, so you collect data. You can think of collecting data at certain time interval. Okay, and you look at the time series data. So this is a time series graph. Along the horizontal axis, you put the time, and along the vertical axis, whatever is your interest. It could be stock price, it could be the population, it could be the GDP, gross domestic product for a country, or it could be the anything that you can think of that relates or dependent on time. It could be the growth of a tree, okay, over time. You're kind of like figuring out how things change, or it could be the pollution level as time progresses. So it could be many things. So time series data is a very important data that is, by the way, very useful. Stock market being the most popular one or common one people can relate to. That's why I put stock market. And the next one is dot plot. As the name says, you create dots. So this is your X and this is your Y. You create XY pairs. So this could be your X1, Y1. And this could be your X2, Y2. There is no magic here, by the way, guys. This could be your X3, Y3. You don't write down the coordinates. You just create the dots, okay? So that's why we call it dot plots. So for instance, this could be, you know, something like pair, data pair. So the main thing, data pair or paired data. Things that you could think of that goes with X and Y, right? X value and the corresponding Y value. So you put it as a dot, so we call it dot plots. This is like your rectangular coordinate system, XY plane, okay? All right, that kind of finishes all graphing stuff. And what it is basically giving you a visual idea, or it's a visual representation of the data so that you can look at the density or concentration of data or the shape of the data or the extreme values of the data. You can visually figure these things out, okay? You can find the center where the highest concentration of the data is, these kind of things, right? Where the highest concentration of data is. Any question, folks, before I move on? Anybody has any question?
No.
Okay. Now we are gonna start talking about measures of center. Okay, that means how we measure the center of data points. Center, you can think of it as the middle of the data, or it doesn't necessarily have to be the middle, but in some cases, middle of data, or in general, you should be thinking of center of data as where the highest concentration of data is. Center of data is where the highest concentration of the data. That's what you should be looking at. Center of data means highest concentration of data. There are different ways you can measure the center, okay? One of them is the mean or the average, which you already have done before. This is something we have done. We denote it by X bar. Remember, this is the sample mean. Sample mean. All right. X bar is the sample mean. All right. Now, let's go ahead and look at other ways of measuring means. But I'd still like to remind you, how do you find X bar? That the sample mean, you add the individual data points. So if you have a set of data, X1, X2, all the way up to Xn, you are going to add all of these data points, X1 plus X2 plus all the way up to Xn, and you divide it by the total number of data points. How many data points? There are n of them because we are using the subscript 1, 2, 3, and up to n, so we divide it by n. The compact way of writing it is summation I is equal to 1 to n x sub I, all of it divided by n, and that's what we have here. Okay, this is Greek letter sigma, uppercase S, I guess, in Greek. So summation I is equal to 1 to n x sub I divided by n. That's your mean or average. Do you guys remember? This is the sample mean, x bar. X bar is the sample mean. What is the symbol we use for population mean? Remember? I told you I was going to ask you. Do you remember that? Anybody remembers? Population mean, anyone?
I'm sorry, what was the question?
What is the symbol for population mean?
Is it the U?
It's not called U, it's called mu, okay?
Okay.
It's called mu, something like this, right? That's what you meant, right?
Yeah.
So remember this. This is the sample mean, okay? And this is the population mean. And in statistics, basically, from sample mean, we try to approximate what is the population mean. That's the goal. We take data from a sample, okay? By sampling, we collect data, and that from that data, we kind of try to figure out or estimate the population characteristics. So from the sample average, so if I want to find out the average number of hours Hartnell students study, I take a sample of 100 students and find their average. That'd be my X bar. And from that, what do I try to do? Get an estimate of what is the average number of hours all the student at Hartnell studies per week, okay? What's the average number of hours all the students at Hartnell College studies per week? So that's what it is. Now, mean or average is one way of measuring center, but there are other ways of measuring centers too. The next popular one is median, and you may have heard of it, how to find median, or sorry, you may have heard of median. Now, some of you may also know how to find median, but I'll show you how to find median. Let's say you have a bunch of data points, okay? -3, 2, 5, 7, 0. I just made up these data points set. If you have a set of data points, what do? You first, to find the median, you first order them from smallest to the largest, or in ascending order. So in our case, the smallest number is -3, right? -3, and then 0, then 2, then 5, and then 7. Amongst these ordered data points, which one is the middle? Obviously, it's clear. It's what? 2 is the middle, correct? There are 2 data points to the right and 2 data points to the left. So this is my median. That's how you find median. You find the middle. Now, some of you might be asking me the question or might be thinking ahead and saying, what if I specifically put 5 data points here? What if I have 6 of them? What if I have 6 of them? Then what do? Let's say I put a 1 here in the data set, add a 1. Then how is my median going to change? So now my data points is going to be -3, 0, 1, 2, 5, and 6. Now the middle is not so obvious. It should be right here, right? Between these 2 data points. And that's exactly what we do. We take these 2 data points, add them, and divide it by 2. So it's going to be 1, plus 2 divided by 2 is 3 divided by 2, which is 1.5. So for this data point, 1.5 is the median. Now you can do median for any data points. What is the usefulness of median? Okay, what is the usefulness of median? That's a question I should be asking. Or why do we need mean versus median? Let me give you an example. Let's say in your favorite city of Salinas, you look for home prices. Okay, so you collect data and you find the following home prices. Let's say 390K. No, let's make the numbers round. 400K, 500K, 550K, 300K, 600K. Okay. Then there is this one home that is $3 million. Okay, 1, 2, 3, 4, 5, 6. Let's take another data point. Let's say 650K. So you have all these homes here, home prices. All of them looks reasonable except for this one. This is, let's make it even higher, $4 million. Okay, this data point is kind of like not matching with the others. This home is super expensive compared to other homes. Now, if I want you to find the average home price, you add all of these numbers, okay? If you add all of these numbers, so let's try it, 650 plus 4 million. So that's gonna be 4,000 plus 500 plus 550 plus 300 plus 600. All of it divided by 7. So average home price is about 942K. As you can see, there's a problem here. If I average all these numbers, I might make a wrong conclusion that the average home price in the city of Salinas is 942,000, whereas it's probably more like somewhere in the 500-600s. What if I take off this data point? Then what happens? Times, then is this minus 4,000? Okay. Divided by 6 instead of 7. Now I can see the average home price is 433K. See, there is more of a reality. So the point I'm making here is that sometimes if you take average, it's not reflective of the reality because there might be extreme data points. Extreme data points, which is called outliers. It's called outliers. There may be extreme data points that's called outliers. Now, in those cases, mean or average is not a good way of measuring the data, but rather median. Now look, if we take all these data points, including 4 million, let's say the smallest is 300, right? Then 400, then 500, $550, then 600, 650, and 4 million. Now the middle of these data points is 550. That means there are 3 data points to the right, 3 to the left, and that's probably more like what the home price in the city of Salinas is gonna be. That is actually, if you look at it, It is actually kind of like that. So median gives a better idea of home prices, where the value now, even though this 4 million data point is there, it has no impact on the medians. That's the main thing. Extreme. Why we use median? Because extreme data points or outliers have no impact on median. Median, even if it's instead of 4 million, if it were 400 million, that won't even have an impact, because extreme data points have no impact on the median, whereas extreme data points have significant impact on the mean. So based on your application, based on the situation that you're dealing with, you're going to be using either mean or median. That's why you hear in the news and media, people don't say average home prices. They say median home prices. Another place you are gonna hear about median is the median salary or household income. Okay, for salary, you might hear average salary, but for household income, they say median household income. Because there are people in Salinas who are making 60,000 a year. There are people in Salinas who are making 600,000 a year. There are people in Salinas who are making 6 millions a year. Maybe, who knows, there might be somebody making 60 millions a year in the city of Salinas. Now, if you do the average, these extreme numbers are gonna influence the average. That means it's gonna make the numbers look bigger in this case. It could make look smaller too in another case, because if you have extremely small numbers, but in this case, it is going to look like, oh, household income is way more than what it is if you use mean. So to get rid of this influence of extreme values, we use median. Remember that. We use median to get rid of the influence of extreme data points. And this is something important, by the way, guys. Remember these things, the difference between mean and median and where to use it. Okay, where to use it. Remember, if you have extreme data points, you're more than likely to use median, so that the influence of those extreme data points are not visible. Now, another way of measuring median, center, is mode. That means sometimes you see there are different clusters or concentrations of data points. That's when you kind of use the mode. One example would be grades in a class. You could see that there are a lot of students who did badly in the class. Let's say this is F, this is B, and this is A. But there are not too many people who did who are in the middle, but there are a lot of people who got A's in the class. So this class is kind of polarized. Many people got A's and many people failed, but there is not much in the middle. So these are the modes, okay, for this data set. Sometimes there are situations where you see modes, okay? If you can have one mode, you can have two modes, you can have more than two modes. So normally, if it is one mode, we just say mode or unimodal. If you have two modes, we call it bimodal data, bimodal. If you have three modes, it's called trimodal or multimodal. So that's what it is. Now, so these are the three ways of, these are the three ways of measuring centers: this. Now there is another way you can kind of measure the center. It's called mid-range. It's kind of quick and easy way of getting an idea. So you take the highest number plus the lowest number and divide it by 2. That kind of gives you an idea of the middle of the data, or mid-range. That's if your data is uniform, then yes, this is a good measure. Okay. That means homogeneous data, kind of. There is not too much distance between data points. They are not sparse. They are not spread out. So Mid-range is going to be highest plus lowest divided by 2. Mid-range is highest plus lowest divided by 2. And then bell-shaped curve or normal curve. Okay, so let's talk about this bell shape. So this is the bell-shaped curve. Okay, it looks like the church bell. Maybe I will try to draw a nicer one. It's a bell-shaped curve. It's also bell-shaped curve is also called normal curve or normal distribution. It is also called Gaussian distribution, who basically came up with the formula for figuring out bell-shaped curve. So he did a lot of work with bell-shaped curve. It's called, it's named after him. Sometimes in the academia, they use Gaussian distribution. So if you hear Gaussian distribution, normal distribution, or bell-shaped distribution or curve, it all refers to this. So this is something we are going to be using a lot throughout the semester. As a matter of fact, most of statistics that we study boils down to properties of bell-shaped curve, okay? Most of statistics that we study in this class boils down to properties of bell-shaped curve. Okay, the last thing we want to talk about in this group is skewness. Sometimes you have data that looks like this. This is skewed to the left. Sometimes you have data you have shaped like this. It is skewed to the right. Skewed to the left, skewed to the right. And then sometimes you have data that does not have a skew like this. It is not skewed either to the right or to the left. Okay, so skewness is very important. So if you look at this, this is where the mode for this data set is. Okay, so the median for this data set is going to be somewhere here. On the other hand, this is going to be the mode for this data set. Mode means highest concentration, where the most of the data, and median is probably going to be somewhere here. So if your data set is, so let me write mode and median. Here, mode and median. Look, for this data set, median is to the left of mode. For this data set, median is to the right of mode. So it is because of the skew. Skew kind of, if you have a skewed data set, mean and mode, median, I mean mode and medians, they switch. And also there is a position for mean. I forgot the exact, there is an ordering. A mean is somewhere in between here. I forgot exactly, so I won't give it to you. But anyway, so keep in mind, if you have a skewed data set, okay, then mean, median, mode, they kind of switch places. Now, for data set with no skew, it has the mean, median, and mode, all of them at the center, right in the middle. For this data set, mean, median, and mode, all of them coincide. Mean, median, and mode, all of them coincide for this data set. Okay. Any question, anybody so far? We'll take a little late break today. I'm just gonna finish it up, right? This topic while I'm in the middle of it. Mean, median, mode. Give one example of situation where you'd use median as a measure of center as opposed to using mean or mode. That would be home prices. Home prices, okay? Or household income. Okay. So give an example of a situation where mode would be more appropriate choice for measure than measure of center then would be mean and median. This could be for categorical data. So think if you have 5 different product lines, 5 different product lines, let's say 5 different products that Apple sells. So they might be interested in finding out mode, okay? Which of these 5 has highest concentration or excuse me, most sales. So in the case of sales, you could think of mode for different product lines. It could be anything, any company selling different products or product lines. It could be for cosmetics, different brands of products, different brands of cosmetics that you're dealing with, which ones have more popularity among the people, which one sells more and stuff like that. Another example where mean would be a better example. So for mean, I use your grades, right? If you take a midterm and if I use mode or median, that might not be a good choice. So let's say we have 3 exams in the class, right? Somebody get 30, 50, and 100 in 3 exams. If I use median, then I'd be using 50. That probably would not be that good for you. On the other hand, if I use average, so it becomes 180, right? Divided by 3, 100 plus 50 plus 30 is 180. That gives you 60. So average for class grades or exam scores would be probably a better choice than mean or mode. I mean mode or median. So this is kind of like general example that I'm giving you. All right, guys. I think we have had plenty of talks. So we'll take about 15-20 minutes break. So let's go ahead and take a break now. So let me pause. Now we are going to talk about percentiles and quartiles, okay? Percentile, quartiles, etc. So this is another way of kind of organizing and getting data, all right? So find the 25th percentile and the 3rd quartile, 75th percentile for this data set. So when you find percentile or quartile, what do? You take the given data set and you order them first, okay? So I should have ordered it before. So now let's see, let's try to do it quickly if I can. -5, -3. Then after that, we have 0. And then 1, how many ones? 1, 2, 3 ones. 1, 1, 1. So this is gone. This is gone, this is gone. And then 2s. How many 2s do we have? 1, 2, 2 2s. That's it. 2, 2, comma. How many 3s we got? 1, 3, 2 3s. Just 2 3s. 3, 3. How many 4s we got? 1, 4. Just 1 4. How many 5s? 1. Just 1 5. How many 6s? 1 6. Okay. How many 7s? Looks like there is just 1 7. How many 8s? 1 2. 1 2. And that's it. 2 8s.
There's actually 3 8s.
Oh, thank you. Thank you. There is another 8. And 9s. How many 9s are there? 1, 2. That's it. 9s, 2 9s. And then what is left? all of these. The first of the, there is no 10, there is an 11, and there is a 12, there is a 19, 20, 19, 20, and there is a 31. I think I covered everything. So you ordered the data set first, okay? You ordered the data set. Now to find the first quartile, the 25th percentile, all right? How many data points do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 data points, okay? There are 23 data points here. Let me just double check to make sure. There is actually that many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There are actually 24 of them. I hope I got all of them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I missed one. I don't know which one I missed. So I won't try to find it. So let's just, for the sake of argument, say that, does anybody quickly see which one I missed? Is there a 4 here? 4, 5? How many 5s are there?
I think you missed number 6.
Oh, I missed number 6. You're right. Thank you so much. Okay. Great. Now, I have 24 data points. I want to find the 25th percentile. So that's going to be 25th percentile, which is what? 25 over 100, right? Then you multiply it by the total number of data points, which is 24. N is 24, or sample size is 24. Okay? So 25th percentile, 25 goes into 100 4 times, 4 goes into 24 6 times. So the number you get is 6. Now you go back to your list and go to the 6th data point. The answer is not 6. You are looking for the data point in the 6th position. Okay? You look at the data point that is in the 6th position. You look at the data point that is in the 6th position. So which one is in the 6th position? First position, second position, third position, fourth position, fifth position, sixth position. So that is going to be your 25th percentile data. Now, that's also called first quartile. How about the third quartile, which is 75th percentile, right? So 75th percentile. So it's going to be 75 over 100 times 24. So this goes, 25 goes into this 3 times, 25 goes into this 4 times, 4 goes into 24 6 times. 6 times 3 is 18. Or we are looking for the 18th data point. We are looking for the 18th data point. Now, this was the 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th. So 18th data point is 9. So this is gonna be your 75th percentile or third quartile. 75th percentile or third quartile. This is how you find the quartiles. Now, there is something called IQR, or interquartile range, okay? The Q3rd or third quartile data point minus the first quartile data point. So Q3 minus Q1. So third quartile data point was, in our case, 9, minus first quartile data point was 1, right? Third quartile is 75th percentile, first quartile is 25th percentile. So 9 minus 1 is 8. So IQR, or interquartile range, is 8 for this particular data point. Now, there is another thing I kind of want to bring to your attention, which is this. What if I wanted to, let's say, find, instead of finding nice numbers, I wanted to get 30 percentile, okay? So 30th percentile, so that's gonna be, let's say, 30 divided by 100 times 24. Now, 10 goes into this 3, 10 goes into this 10, right? 2 goes into this 12, 2 goes into this 5. Okay, so 3 times 12 is 36 divided by 5, which comes out to be 5.2. Sorry, 7.2, I meant. 7.2. Now, what do we do in that case? There is a fraction involved or decimal involved, right? In that case, just only for finding the quartiles, just only for finding the quartiles. Anytime you have a non-zero value after the decimal, non-zero value, you always round it up to the next. So this is going to go to 8th data point. So look, we have 7.2 is going to go to 8th data point. What if we had, sometimes people think it's kind of like rounding. No, it is not rounding. If you were to round this number, this would go down to 7, right? On the other hand, if you had 7.5, it will move up to 8, 7.5 or more. So this is not rounding. You always, even if I had 7.01, I would always round it up to the next number, 8, or 7.99, I'll also round it to 8th position. So we are talking about a position of a data point, not the actual value or anything in this one. So 7th position, 7.2 position is going to be rounded to the next position. That is what it is. So it's going to be the 8th. So this was the 6th data point, 7th, 8th. So this is your 30th percentile, not 35th, 30th percentile. Now, this is a rule you may want to keep in mind. Okay. Another, yes.
Would this be like when businesses kind of talk about their quarterly, like, incomes and stuff like that? Like, they positioned all the numbers to come up with their quarter?
Could
or
be.
like,
Go ahead.
No, I'm just, like you say, just try and reflect it back onto real life. So, like,
Yeah.
say I own a restaurant or something, would this be like how they would come up with, like, their budget, I guess I can say, for like the quarter, the upcoming quarter, kind of estimate?
Okay, that would be more like a percentage. Okay, what you are thinking for a business, it would be more like percentage. Okay, and on the other hand, we are talking about more like percentile. The good example, use case or real world example would be when you take the standardized exams, they have percentile. They use percentile, like you got 95 percentile, meaning that at this score, whatever score you got, 95% of the people scored lower than you did.
Okay, understood. Thank you.
Make sense?
Yes.
Okay, good. So you just reminded me of something. Today, I was just at the beginning of the class, I think I was talking about computer science and Amazon and everything. Just during the break, I read the news that Jeff Bezos, the CEO of Amazon, he's stepping down. Okay.
Wow.
So he's stepping down, and this year you're talking about percentile. As a matter of fact, I have the data points right in front of me on the computer. Okay, I'll share it with you. Let's say their revenue for this quarter for Amazon. So their revenue for the quarter that ended in December was $125.6 billion revenue for Amazon. And that was a 44% increase. There was a 44% increase in revenue from the last quarter in 2019. So this was revenue for the last quarter in 2020, right? For the last quarter of 2019, whatever their revenue was, it has increased by 44%.
44%. Wow.
Yes.
Yeah. Wow. That's a good idea if he steps down now.
Yeah. So yeah, you want to think of percentages in terms of business growth and everything. In the stock market uses percentages all the time. And what is really interesting, another data point I want to share with you guys, this is something very important. People just, many times they take math, but they don't get the opportunity to explore or apply these numbers, basic numbers, into the real world scenarios. So let's see. Okay, their net income for this quarter was 7.2 billion. Out of roughly $125 billion, their net income was 7.2 billion, which is nearly double what they had, 3.7 billion a year ago. In stock market, they compared the results 1 year back for the same cycle, same quarter. Okay, so last quarter of the 2019, their net income was $3.7 billion. Okay, for the last quarter of 2020, their net income was almost double, $7.2 billion. And as you can see, that's how you analyze the numbers. Now, numbers are not just numbers. These are actually telling stories. So in a year, you can see their growth, their revenue has grown, their profit has grown. Of course, we know the biggest growth, this is tremendous growth, doubling your profit in a year. Why did that happen? COVID-19.
Wow.
Wow.
There's so much that I want to say about that, but it just, wow. COVID-19 has made such a weird impact in so many people, and on businesses, how it doubled that, and other businesses it crumbled them.